Hello students, I'm here with another supplementary video that will help you to strengthen your basics of AIoT in civil engineering. In this series, we have already covered a couple of topics in the classroom, and in this video, I will continue with a relook on the covered topics of our ongoing class, and I will add some more details to the discussion so that you will get a clear idea how AI can be related with the civil engineering concepts. So, as mentioned earlier, specifically, I have taken the examples pertaining to the civil engineering from various subfields, and that will help you to improvise your learning. So, let's go ahead. These are the typical slides that we have every time we go through all this, like what is our vision, mission, and what are the outcomes of the course. So I again advise all of you to keep remembering all these details as a statement or as a concept so that you get clarity when you are appearing in the examinations. We have discussed data transmission, storage, and edge computing. In our previous session, the topic was basics of AI and machine learning for civil engineers. We have covered uh, these details, like what was the meaning of the learning. We understood what is learning in terms of artificial intelligence. We took examples pertaining to the concrete technology, like if we want to start with AI approach in self-compacting concrete field, then how the programming and human experience differs to each other and how we can relate it by means of the coding. So we have seen all these slides and discussed also. So I'm just going through all these slides once again, just as a rebrush of the previous understanding or knowledge. We also interestingly discussed the scales where we took some samples with input data and an output data in terms of slump flow. And we observed that what are the missing things, what are the relationship that we can observe through this data, right? So we have discussed, so that's why I'm not repeating all of them. However, this was the, I think, last slide that we discussed in the classroom. And from here, let's now understand how actually the algorithm and learning takes place in terms of AI modeling and how we can use program code in our further exploration. So we have gone through all this discussion in terms of training, testing, and optimization, and finally the interface, how we uh, include or embed training data, and then how we our model can optimize that data, and finally it gives you predicted data also. So we exactly stopped here. So from here, I'm starting. Uh, as far as learning is concerned, we already know learning is a process where the computer program or your code is given with some inputs and required to predict some output or provide some output. So that entire process is the learning actually. But there are several types of the learning happens in the AI field. Out of them, some of the most common and useful for civil engineers that's I have separated, which includes the supervised learning, unsupervised learning, reinforcement learning, and deep learning. So let's go through all this one by one. So it is interesting to know. The purpose of sharing these details with you is just to give you an idea that how you can categorize and how you can select your particular code or your particular algorithm when you are dealing with specific problems or trying to simplify those problems. So the first category is this supervised learning, which means in nutshell we can say that you already know the answer key, right? So the concept is the model learns from labeled data, that is input plus known output. So you just need to give all the known data sets and the output. For example, if we take an example of your class itself, I have all the data in terms of your roll number, enrollment number, name, your country name, all this data is labeled data. So I already have that. Now I want to put you in some categories, like how do I divide the girls and boys. So I just need to label the output as number of girls and number of boys, as simple as that. But this I discussed about generic form. Now, in terms of civil engineering, if we discuss, let's take an example of, again, self-compacting concrete strength prediction. If I want to predict the strength with the help of this supervised learning model, I will be having some inputs like cement, fly ash, water, aggregates, and admixtures. And what will be my output like compressive strength if I want to define it? Then what I will need is I need to have 500 to 600 previously done mixed designs data, and these are the measured strength. So I will have a kind of spreadsheet which is ready with all this data. So if the model is being trained, what it will do is, given the mix, predicts the strength. That is the punchline for this code, or punchline for this training model. What are the algorithms that are popularly used for these kind of known data? Is, let's say, linear regression, random forest regression, gradient boosting regression. All these are the regression type of models, those who learn with different capacities and different categories and provide you the predicted values. So what are the key insights is, it is used when you know the target or output, and our target is prediction. So when your data sets consist input and output together, you can easily use this kind of models. And nowadays it is very easy to create any regression model based on your requirements. I wish and I advise all of you to try with it, develop some, let's say not 500 but at least 100 dataset spreadsheets, and try to develop one code. If possible, I'll share some sample datasheet with all of you that you can use to develop your own code and just see what happens. I'm not expecting that you all become master of coding, but at least you start working with the codes. Specifically, what I personally prefer is the Python. So use Python and try to develop your code. Second is the unsupervised learning, wherein you try to find some hidden patterns which are not known to you, but you still want to explore. That means it is consisting of the unlabeled data, and there are no answer key as such. There is nothing fixed format. So, in this kind of modeling, you require input definitely, but not exactly the output you are predefining. So let's connect this with civil engineering problem like soil classification. If I give input as grain size, plasticity index, moisture content, and other civil engineering, soil engineering related specific data as input, but there are no predefined labels, but the software, or but the code will do the grouping of the like data sets. And for example, it will create clay like behavior, it will also find sand like behavior and silt like behavior. If you embed all this data in your code, it will start collecting the similar or like family like data within the group, and this may reveal new pattern beyond standard classifications. However, I'm just explaining you this in terms of exploring the coding platform. So do not rely upon the predictions or the outcomes in case of unsupervised learning unless you are very sure that you have used the correct type of the let's say coding or regression models. So algorithm are the k-means clustering. These are the best model that is predefined with some rules, and that you can directly use for unsupervised learning, where you don't need to know about final output. So the basic line is you don't know the output, but you can get some pattern discovery or you can have some grouping. So what this kind of software will do is it will collect like or similar data in a specific group and try to understand the patterns which are being developed on their own because of this grouping. So that is what is basically the function of this unsupervised learning type of coding. Third is the reinforcement learning, learning by trial and error. This is little complex to relate, but we are trying. So in this model, the model learns by taking actions, receiving rewards or penalties, improving decisions over the time. So, like it's just like you give us your feedback and we try to learn out of it and then we implement it, and it takes time. After the event has happened, then you can improvise. So, likewise, this model works. Let's relate it with the civil engineering example of traffic signal optimization. Suppose all the traffic control lights are largely governed by some automatic system. So what are the actions? Like the model wants to take some decision or action regarding change of the signal timing. That is the crux of this program or crux of this code. So what the model will try to do is it will optimize the timing, but for optimization, it will first try to reduce the congestion. As a result, the congestion may be reduced, but on the other hand, penalty will be like increased waiting time. A person or the traffic people, I mean the people have to stand along at a given traffic signals. So in this kind of let's say modeling, the model will face these challenges if it wants to take some action in terms of if change in timing is required. It will get reward like reduced congestion, that is a reward, but at the same time it may increase the waiting time. So over the time, AI model will learn best signal timing strategy for smooth traffic flow. This is something which is, I would say, a kind of example that we can relate. So, this is not doable by us because the traffic control lights are not in our control. But however, you can try to relate these kind of coding or learning in some different civil engineering examples also. And that will be a very good small exercise also. So, you try it. There are other examples, as I have mentioned, like construction scheduling optimization. That is a classic example that you can definitely take help of reinforcement learning, and autonomous equipment like smart excavators. It automatically starts, do the work, and come back to the original position. And during that, it gets some reward like fast working, but penalty also as some obstructions or delay in timing or coming back to the original position. So, my advice is you try to relate reinforcement learning with some other civil engineering examples also. And finally, the deep learning, that is advanced neural network. We all know now that neural network is something which is a code or a program that just behaves as the human brain or human neurological system, where it learns also, where it understands the patterns also, where it tries to interpret the results and then finally react to the actions. So a subset, I mean, the deep learning is a subset of machine learning using multiple layer neural networks. You all know that there are primarily three layers in any of the neural network. I'm very talking about very basic things like one is input layer, second is hidden layer, and third is the output layer. Now, if you keep on increasing these layers like input, except input and output, the middle one is the hidden layer. If you keep on increasing these layers, your decisions will be more refined and mature. To learn, the subset of machine learning using multiple multi-layer neural networks to learn complex pattern inspired by the human brain. Let's relate this with the civil engineering example. Here I've taken the crack detection in the structure. Now, the if we can say these are the positive sides or negative side, that we will discuss later. But in terms of input, we can have photographs of the cracked concrete structures. There are several types of cracks, and I think you have already learned, and you can see also around your structures, infrastructures, you can see a lot of cracks. So if you start taking pictures of these cracks, and then you create your database as input, collection of the images, what will be the output? Like, crack detection will be the output. However, your program will tell you what is the severity of the cracks. I would inspire all of you to encourage all of you to do this in a real check also. If possible, if you have time, you just collect as many pictures as you can. Just click a picture and save it as your data set, and taking help of the other chatbots and all other tools, you can actually do this in your own interpretation. So collecting the pictures or images of the cracked concrete structures, and your program will tell you that whether the crack is severe or not. The model will automatically learn about the ages of the cracks, about the shapes of the cracks. You know the pattern of the cracks. Some are linear, some are non-linear, some are straight, some of them are longitudinal or unshaped or undefined. Many other patterns are there in cracks, surface cracks. So these all things will be learned by this deep learning model. So in a way, we can say that when your data is not linear, or I would say when your data is more scattered or complex, then you should use these deep learning concepts where the neural network comes into picture. So okay, so these are the applications. Structural health monitoring. We can do structural health monitoring by doing this. Drone-based inspection, damage detection after earthquakes, and all these similar problems you can try to solve by using this deep learning. If you create a code, if you create a program that gives you these kind of predictions or output, not prediction, but the output, it will be a good learning concept for you. So try it if possible. What are the algorithms? The most popular algorithm, that is artificial neural networks, that is a very popular, very matured kind of code that you can embed in any platform like Python very easily. Very standard algorithms are available that you can use. So try it. And what are the key insights for this is the data is complex, as I said. You may use images, videos, and other things, and your goal is high level feature learning. So you know now the feature learning, that means what is a feature that already I have roughly discussed, but now we will go into the detail of this also. But this is what I wanted to discuss with you, that there are four types of learning. When to use what type of learning, we have briefly discussed. So that's the table which includes the summary of this learning: supervised, unsupervised, reinforced, and deep learning. What are the data types? Labeled, unlabeled, feedback based, and large and complex. What are the examples we have discussed, like strength prediction, soil clustering, soil type clustering actually, traffic control, and crack prediction. And what are the goals will be, like predicting the output, finding the patterns, optimize the decisions, and learn complex features. So let's quickly discuss the pros and cons of each of this learning. Let's start with supervised learning. It gives you a very effective it is very effective for problems like concrete strength and slump prediction, when it is sufficient data is available. It gives you a clear performance evaluation also. Statistically, you can evaluate the predicted data in terms of R square, that is the coefficient determination, or root mean square evaluation. Likewise, you can confirm the predicted values accuracy. However, there are some limitations, like it requires large labeled data. As I said, when we say 100 data, it is very easy to say, but it's very difficult to find similar 100 type of real or actual data. Nowadays, the generative AI, with the use of generative AI, you can use the let us say synthetic data also, but I won't advise you to do it. Just this is just for a discussion only. If by chance you get some good data, because there are some websites which gives you these kind of data, you may explore. So if it is possible for you, collect the data, right, and then use them. Then the second limitation is limited generalization beyond training data. Uh, it may perform poorly for new materials or unusual mix combinations. When you change mix combinations, the rules are not set, so it may not give you exact values. The unsupervised learning, there are pros and cons. The positive sides are no need for labeled data, and it can discover hidden patterns. However, on the other side, the results can be difficult to interpret. Suppose the grouping is done, but what you will do with that grouping, that's up to the user. So, with what aim or objective you are implying the unsupervised learning is very crucial and critical. So, kindly focus on these content only if you are very certain about what you want to do after getting the patterns. And second is no prediction output, no direct prediction output. So there is a very rare case where you can use unsupervised learning for prediction purpose, right? So be careful when you are why I'm discussing all this, because you can be assured that when you are selecting a particular type of learning and eventually the code model, you should be very clear what is your purpose and what you want. The third is reinforcement learning. There are positive side, like it optimizes decision making over the time and adapts to the dynamic environment. So this is a kind of real environment where actual conditions are being handled and being learned by the model, and based on that, it is also in parallel, it is optimizing the decisions as well. However, there are limitations, like it requires extensive training time. It cannot be done overnight because it has to learn the real pattern. Every day it should be the real data which is being fed to the computer system or the data system, and based on that, the model keeps learning again and again, because every day the actual occurrence of the events will be different. Second is difficult to implement in real world system. So let us we can assume that it is very rare that same traffic pattern, same thing, same type of vehicles, same type of density of the vehicle will take place at the fixed connection, fixed joint, or fixed crossroads. So when we are trying to relate it with traffic, it is very difficult to generalize it. So that is how you need to, which means it's not impossible, but you require some, specific learning or specific code knowledge, which you can include in your learning framework. So that's why this is just for your understanding that how reinforcement learning takes place and where we can possibly use them. Finally, the deep learning, what are the positive side and negative side? Like positive means it is excellent for complex data and automatic feature extractions. There is no need to manual feature engineering, unlike ML models. And there are some limitations. It requires large data set and high computation. You can imagine that one image can can occupy a lot of space. So if you are inbuilding 1,000, let us say even 500 images, the amount of data that is generated and being handled by the code is very high. Second is it's like a black box nature, low interpretability. That means it's difficult to explain why a crack was detected or a decision was made. Let us say by learning the images, it is like almost like a robot. You when you give 500 images, it will definitely identify some pattern and try to give you that what is the severe crack means. But why it happened and what happened to the surface, what are the causes, it's very difficult for the model to interpret. However, it's not like that. You cannot embed some more programs which are smart in nature. But for a typical programming, like a neural network, when you are using, you cannot identify directly that what may be the cause of that crack. You can only analyze the existing situations. Even though this is a very good feature, and I would say you should not stop with their limitations, try to go beyond your actual learning in the classroom or through these videos. Just try to collect some images and just put them into the code that you can develop using chatbots and all, and just see what happens. If nothing happens, don't worry, you just tried it. I wish that the all the students should try at least with working with some codes, primary codes, and with meaningful learning. That at least you'll come to know that you don't know this and you should learn this. That is the purpose of this, exercises, small exercises. So that's a summary table. What we discussed is learning type, pros and cons, supervised, accurate and measurable. However, it needs labeled data and limited extrapolation. Unsupervised learning, that is no labeled needed, and it finds pattern automatically. However, it's hard to interpret and there is no direct prediction. Reinforcement learning is like it optimizes decisions and it is very adaptive, but it is time consuming and complex in implementation. Finally, deep learning handles complex data, uh, and it also gives you auto features. However, data and computation is very heavy and it contains black box nature. In the last few minutes, let's discuss one more important thing, that is data pre-processing. We have already discussed that for any code or any generative, to generate any of the program, you require data. But there is something which is called pre-processing. It's almost like when you wash the vegetables before you use them. It's as simple as that. So you are cleaning the vegetables before you want to use them. So similarly, the data should also get cleaned, get modified, get appropriately normalized before its usage. So for that, I have taken one example here. You can see a small table where cement, fly ash, water as super plasticizer and slump flow are given. The values are given. Irrespective to the units, just focus on the values. Now, these are some questions pertaining to it, like is there any missing values? Yes, there are some missing values. Is it any wrong entry that you can detect? Yes, if you see in cement, the third entry is something which is not acceptable or something has gone wrong over there. Instead of 400, it has become 4,000. And is there any inconsistent data quality? Yes, again, you can see that some of the data like fly ash is not consistent, some missing values are there. In a water also some missing values are there. So if something is not inconsistent, again the super plasticizer, you can see one value is 1.0 and rest of them all are less than 1. So these small things but very important things, because see, computer cannot directly understand, or the coding cannot directly take that which data is to be retained or which data is to be removed as far as your basic learning codes are concerned, right? So you have to go for data pre-processing. So this is the process where you can refine the data. So what are the steps involved? First of all, the data cleaning, fix the errors and remove noise. Noise means something which is not uniform. That is the noise, right? So replace missing values or correct the values which are wrongly entered. Uh, in second step, you can see that handling of the missing values. If you code it properly, then your code itself will fulfill the requirement of missing data also. Like by taking an average, whatever is the, let's say you have 10 data sets and two are missing. So based on the averaging pattern, it will try to fulfill this data. However, it's not a good practice, but it can do it by its own. Then third is the feature scaling. Now you just have seen in the same table on the right side also that cement is given in some values, fly ash is taken in some values, with values means some units. So it is not necessary that all the data that you are collecting are on a same, let's say, units. Let's say cement is in kg per meter cube, fly ash is also kg per meter cube, water may be in liters, super plasticizer is always used in percentage, slump flow is measured in mm, right? So the units are different, which creates or which may create a challenge for a code to interpret all this data and use them effectively. So what is the solution? The solution is to normalize them or to have a standardization. You can, I mean, not you, the program can also give you a kind of scale based on which you can normalize. That means you can do a common value for each and every data based on its average or original data. So, for example, bring all the variables on a similar scale. In a cement, 300 to 500 kg versus super plasticizer 0.5 to 1.5 percentage. So, if you scale this particular values and then you normalize these values, it will be more helpful to the program and code to give you the exact prediction. Next is the feature engineering, like create new meaningful parameters. For example, water to cement ratio. If you have given the water and cement, if you write some code, it will generate water to cement ratio. Pest volume, it can extract the values of the, let us say, water, cement, and the pest that has been developed. And from this slump flow results, it can create some pest volume also. Aggregate ratio also, here we have not mentioned aggregates, but otherwise, if you have entered the data for aggregates, it can again give you a kind of aggregate to binder ratio. So all this specialized relation based, or I would say ratio based features are called feature engineering. So your code can also develop features, or otherwise in advance you can develop some features or you can identify some features. Nowadays the research are being done on the basis of all these features already. So there are good chances that you will get all these features readily available from the research data, research publication data. You can collect them and you can enter them. So eventually this feature engineering concept will help you to predict the final output in a best accuracy. Finally, removing the outliners. If nothing doing, the program or the code can remove wrong entries. That is, outliners means wrong entries, right? Something which are not fit exactly in the system, in the given data set system. For example, here the 4000 kg was the reading which was not uniform. So what the code will do, it will simply remove it because considering it as no, it's not realistic value. So this is how the I gave you the very brief idea of what is known as the data processing. So always remember the vegetable principle. Whenever you are starting cooking, you just clean the vegetables with water. This is the same system that we have to adopt when before you use your data. Otherwise, you will end up with wrong prediction and inappropriate, outcomes of your coding and will waste your time and energy. So finally, these all are the three different, let's say, prediction models that we have to discuss very quickly. Like, these are the models which are useful for us to understand, to create the code, similar to the learning, which learning is to be adopted. This is also similar to what kind of model you can use. The regression, it predicts the numerical value for civil engineering context, predicting the compressive strength or slump flow of concrete based on the mixed proportions. Input is given, output is observed as strength. So output is continuous, it is in numbers, right? So when you can use this regression model, means everything is very uniform, everything is very continuous, right? Let us say output and input and output are just numbers, so you can definitely use them very easily. Clustering is another kind of, or the grouping is another kind of model where it is used. It groups similar data without predefined label, just like unsupervised learning we have seen. Grouping soil types based on properties like grain size, plasticity, and all. Output will be clusters such as sandy soil, clayey soil, and silty soils. So, when to use this? If you want to discover patterns or categories, this is, you can see now, this is exactly matching with our earlier discussion of which type of learning you should use. We have seen four types, so these three are relating with each of them. Finally, the decision trees, like rule based models, and this is, I would say, directly matching with your ANN, that is artificial neural network concept also. What it does, like, it makes decisions using if or else rules. You know, if this is happens, that is true, otherwise another thing will be true, like this, if and else, very well. So civil engineering examples, let's say classifying the quality of the concrete, whether it is a good concrete, medium concrete, or poor concrete, based on what parameters: the water cement ratio, curing conditions, admixture content. Just to give you an example, if you have defined that if water to cement ratio is greater than 0.6, definitely the concrete mix is of the low strength. So that is the rule set. Now, what your model will do is if and else, loop will start. If the WC value is 0. Let's say W by C value is 0.6, then it will directly say that this concrete is of low strength, must be of low strength. Why? Because you have already defined this rule. If you have water to cement ratio is let's say 0.45, it will detect, or it should detect, that it is a normal or good strength of the concrete. So when to use these kind of decision trees based models is, you need to you need to interpret the model, or when you want to go rule based decisions. So in these times you can utilize this decision based trees based model. So this is nothing but the pictorial presentation of all these three types of models: regression, clustering, and decision tree, which you can refer later on. Also, I'm going to upload the slides also in your e-content, where you can read them properly. And finally, we have reached the quick recap session. We just discussed meaning of learning in the classroom itself. Then we went for types of learning in AI. What are the models for learning in AI? Just we finished. What is the feature selection or transformation of the data to the normalized data? That also we have discussed. And what is the pre-processing of the data? So friends, with this quick session, I will stop here, and we'll meet again in the class that is on Tuesday. Definitely we'll have a recap again of all of this concept, and we will go ahead with our next unit. So till then, keep learning. Please try some codes, some basic things in Python. It's very amazing field, and emerging field also for civil engineers. So I really advise to all of you that even if it is out of interest, let you fail first time, don't worry, keep trying, keep learning. It's very very easy, and of simply available everything on online mode, right? So try it. Okay. So we'll meet in the class. Till then, take care. Have a nice day.